Welcome to Humans of Reliability. In this episode, we speak with Swizec Teller, Tech Lead Manager at Plasmidsaurus. He's a conference speaker and author who recently published a new book, Scaling Fast Software Engineering Through the Hockey Stick. My name is Sylvain Kalash. I'm the head of the Rootly AI Labs, and I will be your host for today. Let's dive into the episode. Swizec, you recently wrote a pretty thought-provoking, at least for some people, article on your blog called The Future of Software Engineering in SRE, and I encourage the audience to read it. And you speak about how writing code is cheap or easy, and especially now with Gen AI. And you argue that reliability was always the hard part. Can you expand a little bit on that? And can you maybe, especially I think for people who are not SRE or who are not exposed to this practice?
Yeah, so for the record, I am not an SRE. I just have always worked in relatively small startups where you always own your own software and you're responsible for keeping it running in production. And I think that as software engineers, we often think that people buy our software. They buy a pile of code to run and do something with. And sometimes that might be true, especially if the other user is a software engineer. They're probably using your library because they want a pile of code. But realistically, what people do is they hire a service. They don't want to think about your software. They want the software to be invisible. And, a pile of code is like a hobby car. It's fun to work on a car, but it's not fun to work on a car that you need tomorrow morning to go to work. You just want the car to work. You want somebody else to make sure it keeps working, and you don't want to think about it. When you turn the key, the car should turn on, and you press the gas and you go. You don't want to be like, okay, did I remember to tighten all the screws yesterday? Does it work today? Will I be able to get to work? You just want the damn thing to work. And I think that's always been the hard part of software. It's easy to do the first 90%, but then the other 190% to turn it into reliable service. That's where the secret sauce is, and that's why all these big tech companies make the big money.
And oftentimes it's almost like the long tail, right, of whatever you are building or, as you say, offering as a service. I feel especially in the area of microservices where you build a lot of small building blocks, and ideally you build one and then you don't touch it. But then you still have to maintain it as long as it lasts, right? So there is no kind of end of life on this project, never really stops. In your blog post, you speak about Feynman computer disease. Yeah, how do you see that showing up today, especially, in the era of Gen AI?
For those who don't know, the Feynman computer disease is something he talks about in, I think, Surely you're joking, Mr. Feynman. And I think it comes from his time at the Alamo, where they were building the atom bomb. He talks about how this guy, who was one of the earliest people to use computers, got really excited about all of the things that you can make your computer do. You can automate this, you can automate that, and then you're tinkering and you're making it better and better. And the whole time you forget that, hey, you know what? You don't need to make your computer calculate the tangent of an angle or whatever, because there's a perfectly good table that you can use. It's been pre-calculated since the last few hundred years. You can just look up your angle and you know the number. You don't need any of this computer stuff. But it's so much fun. It's fun to make computers do the work for you. And once you get started, it's really fun to figure out what more you can make the computer do. And I think we see that a lot especially with AI coding and agentic coding these days. Especially on Twitter, you see a lot of people talking about what they've gotten these agentic swarms and AI, what it can do for them. And honestly, you very quickly realize that most of these people are just spending time spinning their wheels with agentic coding and getting the AI to do things. And it probably would have been faster if they just did it themselves, maybe higher quality as well. Probably less fun, but I see this a lot when actually this happens to me a lot. I will go, oh, this is a cursor one shot. I can just ask cursor to do this for me. And it gets it like 95% right. I'm like, oh, damn it. It didn't work. And then I fix my prompt and I try again. And it's like, it didn't work again. And then suddenly it's like 3 hours later, I finally got it to work. And it was like, wait, I could have just done this myself in like 10 minutes if I got myself out of just one more try. I guess it's like a slot machine in the end. You just one more pull, and this time it's going to work for sure. Just one more bug fix.
Right. I mean, yeah, the Gen AI coding assistant are definitely kind of addictive, right? When you get into it, and as you say, you see the magic appearing. Have you been able to now, like, work on, like, do you have a methodology to avoid going down this rabbit hole of, like, hey, one more coin in the machine type of situation?
Oh man, I don't really have a good solution for that. One thing I have noticed is that the agents are, for me personally, I like to use them from Slack. So I use cursor background agents a lot directly from Slack, because as soon as I'm watching the agent do its work, or as soon as I'm babysitting, I feel like I'm wasting my time. I don't want to be babysitting them. So I think that agents are really useful if they're really in the background somewhere in the cloud and you're not thinking about them. As soon as you're sitting there working with the agent, maybe it uses a little bit less brain power to watch it work than to do the work yourself. But at that point, you're essentially pair programming and you're not actually saving any time. So like while the agent is spinning its wheels, going through the process of thinking, talking out loud, I find it very hard to not read along when there's text on the screen. So then I'm like, wait, I'm not multitasking. So I'm not getting any more done than if I was just doing this myself. I'm just kind of sitting here twirling my thumbs and waiting. Whereas if I do it through Slack, I don't get into that loop. I can just be like, cursor, do this thing. And then I can go do other stuff and I get a message back that says, hey, I think I did it. And then usually I still have to go test it. But that lets me not sit there babysitting it's kind of like when you're pair programming with someone, you're like, just do it faster. It's like, no, you're going down the wrong, stop thing. But if I don't see that, then it's fine. It happens somewhere in the cloud. And if you are using agents, I strongly encourage you to not babysit them.
Not watch. It's funny because you made the analogy of a slot machine. And when you think about it, it's a bit similar because like people who work on slot machines, they like look the animation and, back in the day, it was this simple, like 3 things. And now a lot of these slot machines are digital. Like you have a lot of like cool animation, right? And character and graphics. Sometimes I think it's some stories. I don't play myself, but there is a casino next to me. So I've seen people playing it and it's part of the experience, right? And you get addicted to this and the result. And I feel there is a little bit of this with this coding assistant, right? Where you see them working as engineer, it's kind of like really cool to watch and fascinating and satisfying. But as you say, like in terms of productivity, may not be the best use of our time, right?
Yeah, exactly.
So your blog post like completely like blew up on Hacker News, which is always fun because then you get a lot of reaction and people on Hacker News tend to go very far in their opinion. And one of the community members said that he believes that basically the future and getting back to the SRE topic, is SREs chasing down LLM fires. In your opinion, and I know you are not an SRE, but in your opinion, do you think, that's what's going to happen, or in practice, it's not really happening?
I mean, I guess it kind of depends on what you mean by chasing LLM fires. I also saw some people were saying, you're just saying SRE is the last paragon of software engineering just because that hasn't been automated yet, but that will soon be automated away anyway. And I don't know, maybe Anthropic actually just released a paper, I think last week. Maybe it was not Anthropic, but somebody released a paper last week saying that they developed, I think, Hotel Bench, which is literally a benchmark for SRE agents. And the best LLM agent was currently able to complete, I think, 30% of the tasks successfully, which is pretty good. Those were probably the really annoying repetitive tasks that aren't that useful. But the problem with SRE is that to do reliability well, you really need to understand the whole system. You have to understand how everything fits together at a very macro level. It's not just, I look at the log and then I debug the thing from the log, or, I put in a log and then I have logs that I can look up or set up observability. There's a lot of art. I see this a lot with like more junior engineers. You tell them, hey, add logs so that you'll know what's happening in production. And they add logs, and those logs are completely useless when you're trying to debug an issue at 2 a.m. when you get paged. But then you have someone who's more experienced. They put in a log, and the logs literally look the same. When you're looking at a PR, it's like, oh yeah, the junior put in a log, the experienced engineer put in a log. They both look like logs to me. But somehow when you get paged at 2 a.m., the experienced engineer's log is super useful, gives you all the information you need, and the junior's log is hard to even search for. Or you search for it and it's like, oh, actually they used the same prefix for the log in 5 different places. So now from the log, I don't actually even know what's happening. I just see a log that could mean 5 different things. So I think there's a lot of very subtle skill in SRE that I don't even really know how to describe it. It's something that you learn from experience, from running your own systems in production, getting punched in the face a lot, and you figure out which logs are useful and which aren't. There's rules of thumbs that you can use. You can ask more experienced colleagues. There's probably also lists online. I've probably written some where it's like, put these logs in. These are the ones that are going to be useful. These are the ones that are not going to be useful. We actually, back in the current company I joined way back when I first set up Hotel, we had a Lambda that was producing 1.5 million logs per day. It was blowing up our Hotel bill. So we were like, wait, this is weird. Why is it producing so many logs? It only gets called like 50 times a day or something. And we cleaned it up, cut our logging bill by like an order of magnitude. And we realized the person was basically every 2 lines of code, there was a print statement. And that all went into CloudWatch and got slurped up into our logging provider. And they were like, wait, you don't actually, this is a system that runs in production. You don't need to look at a whole trace of what it's doing. You just need logs that an error happened or I started doing a thing. I feel like I went off topic, but there's a lot of really subtle things that go into SRE that I think take a lot of experience to learn. It's not straightforward, and you really need to, at the end of the day, especially when you're debugging these modern distributed systems, God forbid if you have microservices, there's a lot that goes into really understanding the entire system at a global level. There's a lot you have to understand about how computers work, how websites work, how these systems work, that can be really hard to debug. And we also had a case the other day where we were trying to figure out why something worked in development, but it didn't work on exactly the same system in production. We were so happy. We just got on Terraform. We had the exact same development in the exact same production, except it worked in dev, but it did not work in production. And we were all super stumped. And it actually took a lot of iteration, even with ChatGPT, to figure out that there was one variable in engine X that we called $schema instead of $forward.for. And that confused our servers, and it went into a redirect loop from HTTPS back to HTTPS. I don't even know how an LLM would even begin to debug that. If you don't, at the very least, you have to know how to ask the LLM the right question. I feel very vindicated because our DevOps/IT guy was like, okay, Swiz, let's try what your LLM hallucinated and see if this worked. And then it worked.
It worked, yeah. Well, I mean, actually, it's fascinating. I think what you say, SRE is, the way I like to call it, it's almost like an instinct, right? The best SREs have been around the company for a while. As you said, if you have a distributed infrastructure and all these microservices, takes a lot of time to kind of map this through your brain. And the larger the company, if you speak about the company, the Google size, you can never actually map it all through your head. It's impossible.
Plus it's changing all the time.
Exactly.
There's dozens, maybe hundreds of engineers making changes every day.
How do you map this? I think, humans have this map of hey, I know, as you say, maybe the kind of knowledge as Terraform type of, describe, but then there is more than this. I think there's also the business, right? You may have business logic that maybe written down somewhere, or you know about it because you're attending meetings. There is like all the chatter on Slack or Microsoft Teams or whatnot, right? There is a lot of context. There is a new type of tool. I don't know if you've heard about it, called AI SRE, basically coding agent, but specialized for SREs. The most advanced one will plug into your Slack, will plug into your Confluent, will plug into your incident management tool and monitoring and whatnot. We'll be able to develop this kind of like instinct or intuition that we just spoke about. Because as you said, it's not just as simple as reading logs. Like you need to look at kind of like the history and how your system is built. We are building one at Rootly, and it impressed us, like, because it has all this like background knowledge about that. I'd actually like to, after we are done with the podcast, I'm going to look into what you said regarding the benchmark, because I'm running the Rootly AI Labs. And one of the projects we have is kind of what you described. It's called SRE Skill Bench. And it's a benchmark that's kind of similar to Swebench, but for assessing LLMs on SRE type tasks. For now, it was a simple, like, multiple choice, question and answer format, but LLMs are becoming so good at solving it that, we are reaching nearly we are like 94, 95%. Wow. Yeah, it's quite impressive. So the second version is going to be one where the LLMs have to perform SRE type action using Terraform, and it's already struggling more. But the next one I want to do is to build like a benchmark that's going to test this AI SRE, which is more than just a model, but as you described, like this agentic, tools that use LLM. When there is an outage, you need to have the instinct to know what to prompt the LLM, right? To go look for the right piece of information. It's not just, hey, debug, troubleshoot this. And I think this AI SRE have this kind of instinct of how do you structure this. But anyway, getting back to your blog post, and I think we touched base a little bit about this, but you are when you are trying to keep an application up and running, you speak about bugs and broken dependency and team breaking each other's code and things like this. How much do you see this being, automated, or at least drastically help with LLM versus, hey, the human will still need to be involved deeply, for foreseeable future?
It's really hard to say because the LLMs have been improving very quickly. Like if you remember 2 or 3 years ago, it was barely able to write code. Now they can do a lot of really interesting things. So who knows? In 3 years, it's really hard to say. I think what is going to happen is that, for one, right now, tokens are extremely subsidized. I think we're way underpaying for how much these things actually cost to run. If it ends up being costing as much as half of an engineer or as much as an engineering salary, the math really changes on that, right? I think the big thing, a lot of what makes people write good code, in my opinion, and I talk about this in my book as well, is that you really need to own your own systems. So the model of SRE or DevOps, where engineers write code and then throw it over the wall to somebody else to host and run and test in production, that doesn't really work. That leads to really bad software, etc. You need engineers who own their own code, so that when I always like to say, hey, I reviewed your PR, it probably works, and we have your phone number if it breaks at 2 a.m., So if you think if you can sign it with your phone number, then we'll ship it to prod. LLMs don't have that, right? There's a famous quote from IBM, I think even from back in the 60s, that a machine can never make a decision because it cannot be held accountable for that decision. And I think that's the world we're kind of going into. You're probably going to use agents to write your code, or at least part of your code. You're probably going to use agents to run your code in production. You're going to use things like Rootly or whatever to help you debug things in production. But there still needs to be a human somewhere who is responsible and whose job it is to make sure it's working. Someone whose phone number we can call and be like, yo, fire up the agents. It's 2 a.m. We have a customer who wants to give us $1 million and they're saying it's broken. This better be fixed right now. But I think ultimately a lot of it is about, we do microservices, we write APIs, we do all of these things because most engineers are already kind of like agents. They don't understand the whole system. They understand the area they work on. And we try to make sure that we give them guardrails and safe sandboxes to play in. And I think it's going to stay, that part is always going to be true. It turns out that if you factored your code well, if you build vertical services that own business processes, if you use type systems, all of that stuff, the agents do better. It makes it easier for humans to write code, makes it easier for LLMs to write code. All of the same things still apply. You want to reduce the amount of context you need to know to write a feature. You want to make systems that yell and scream and throw alerts when something's wrong. When I ship a service and I break something 5 services down, I want to find out about it as soon as I can. I don't think any of that is going to change regardless of who is writing the code.
Recently read that an analyst did a survey inside a large, I think it was a bank, large company, interviewed engineer about incident management. And one of the questions was like, hey, how do you feel about a specific like incident, whatever it was? And one striking thing that this engineer said is that, hey, I didn't cause this outage. GenAI did, right? Even though, this engineer prompted the GenAI to do it. So I think, that I love what you said about, hey, like, as long as you put your phone number on it to quote you, we're good to go. But the reality is that probably, most people now who use GenAI are not reading their code base, which potentially could mean that incident might be harder to troubleshoot, because as you mentioned, right, if it's, there is a serious incident and like the SRE cannot troubleshoot, it's like, hey, come next to me or come on the phone, to help me troubleshoot it. But there is a chance that the engineer doesn't know more than the SRE, right? I think that's the world we're entering.
Yeah, but I think that's always been the world we were in when you think about libraries and vendors. I think Charity Majors has a good post up about you own your dependencies or you own your vendors. As a user, I don't care that AWS is down. I care that your website is down because I was trying to do something right now. Or like, I can't use Notion and write my notes because AWS is down. I don't care. I just want to write something down and I'm using Notion for it. And the more that it's unreliable, the less I'm going to use it. Like even in the real world, do you care if the supply chain went down and that's why you can't get your matcha at your favorite coffee place? You don't care that you just know that they don't have matcha. It doesn't matter if it's because the delivery driver was late or because the matcha company they use stopped producing matcha. You just want your damn coffee. And it's the same in our world, right? It doesn't matter if it's Gen AI or if it's a vendor. If you have shitty vendors, switch vendors, make them sign SLAs. And that's the other thing that I think some engineers don't realize. In the B2B world, it's very common to, we say, oh, we have 3 nines, we have 5 nines or whatever of reliability. That comes with serious SLAs. When you're in the grown-up world, somebody somewhere is signing on the dotted line saying that if we don't have 5 nines in a month, that will cost us a few $1 million because the other companies want to rely on you as a vendor and they make you sign legally binding contracts. And at the end of the day, it doesn't matter how you produce that code. It just matters whether you're meeting your SLAs.
Getting back to your article, Swiz, you kind of, in some way, kind of want to say that, and you just said it, like this reliability skill matter more in many ways that, that the coding and the more we ship code and now, writing code is becoming a commodity, like it's becoming more and more easy. Do you think that developers or software engineers, I may say here, should start thinking more and behave more like SREs to keep up and stay relevant?
Yeah, I think so. I think there's going to be more people who get into programming or who become software engineers. We're going to have more code. It's going to be less inspected, less understood, more probabilistic. So I think the whole SRE angle is going to matter a lot more because it's going to be all about how do you make your systems reliable when you have all of this probabilistic code. You're probably going to need more tests, more observability, more of those things that make unreliable stochastic processes reliable at scale.
Well, I love that. Like, I think we speak a lot about how LLM are non-deterministic. Generally, that's like and especially for SRE who are trying to make system as you know, like you want them to be able to have them like as deterministic as possible. But here you use the word probability, which has always been right, because also humans are non-deterministic and we make mistake. But you see, in your opinion, you seem to think that this probabilistic code is going to become more and more unstable, right? Is it what you... Right.
Yeah.
You know, there is a lot of anxiety in the industry because the pace of change is very quick. Like, you know, I think if you've been in the software industry for a while, as many of our listeners are, you know that there is always this like anxiety that's building when there is like a massive jump in technology. You know, this time people are like, oh, it's not the same. But with agentic coding, do you think we'll need more or less software engineer, and why?
I think we're going to need more. I think there's going to be more people who think of themselves as software engineers, so we're automatically going to have more. But, you know, I think a lot of this stuff is really good for prototypes. I think of it a lot as like the no-code movement and all of those others, or even spreadsheets. When people started using spreadsheets, that's probably the most used programming language in the world is Microsoft Excel. People write these things. It's really good for prototyping business processes. It's really good for people unblocking themselves and getting things done. But then when it comes time for serious production, when it comes time to run a multi-million-dollar business on top of this, they suddenly realize that, hey, you know what? Being able to take a vacation and the whole company not falling down is nice, or not being the only person responsible for this spreadsheet running is really nice. Or you're in a business meeting and something breaks, you want your engineers to go deal with that, right? So my experience with all of these automation tools has been that the business users, you know, we've been trying to get business people to write code for us since we invented COBOL. The original COBOL was about, we're not going to need software engineers anymore because business people can write their own code because it's so easy and it's like English. It turns out nobody wants that. When somebody gets called at 2 a.m. because the code is not working, they want a software engineer to deal with that, not the business consultant who's charging $10,000 an hour or whatever. So in my experience, it's always been, we've built this really cool thing. It's amazing. Hey, Swiz, people keep asking us about bugs. Can you fix this for me? Can you own it from now on? I don't want to think about this anymore. I have other shit on my mind. And I think it's going to be the same with LLMs and with agents. It's going to help us move faster. It's going to help us build prototypes faster. But when it comes to the serious engineering, when it's time to run this in production for realsies, when the stakes matter, I think that's still going to fall back on software engineers. And because there's going to be more code, there's going to be more of us that have to do it.
Absolutely. And I think a lot of people are afraid because, yes, you know, you could, hey, I can replace one senior software engineer with a coding assistant and replace like maybe 5 or 6 people. And the company might choose to do this, but maybe the competition is going to be like, you know what, I'm going to hire 10 software engineers and move much faster. And so it doesn't work for this company who try to reduce cost, right? So it's not as simple. I think otherwise it's going to be a game where everything is going to sum up. Can you tell us a little bit about your recent book? And also, if people want to find you on the internet, where can they find you?
Yeah, so Scaling Fast. If you go to scalingfastbook.com, you'll find my latest book. It's about building hypergrowth startups. It's kind of like half business, half technical book. The full title is Scaling Fast Software Engineering Through the Hockey Stick. And it's about what happens to your software engineering practices, to your teams, etc., when you go through the inflection point of hypergrowth. And I talk about, it's not about AI, but I talk about a lot of the things that will also help you with AI, about how to structure your code, how to do architecture at a high level, what it means to run services at scale, how your teams change, all that good stuff. So you should check it out. I think it's a really good book. It might be useful when you suddenly find yourself being a manager of 5 agents.
Yeah, we are all becoming managers. Well, you have a blog. Where do you hang out? Where can people get in touch with you?
So I'm on Twitter. I'm on Blue Sky. Those are my primary social networks these days. Swizec.com is my blog. Have a newsletter. But if you type my name into Google, you should be able to find me.
Amazing. Thank you for coming on the show.
Thank you for having me.